All right, so warm-up number 70 was to flip a coin 8 times, make a table, record the frequency of each outcome, and what kind of probability is this? So, everybody done? Yes? All right. So share with your neighbor, and I'll get somebody to get us started. See what you got. All right. How about Amy? Let's see. What you do to record your flips? A table, okay. Nice and straight like mine? Okay. And then? Okay. So, it looks like out of 8, tell your neighbor what's the probability of a heads according to Amy's tosses or flips, and the probability of tails. All right. Maddie, so what was the probability for heads? 3/8. And the probability for tails? 5/8. Okay. Hands if you agree with that so far? Yes? Tell your neighbor what kind of probability this is, please. What kind of probability is this, Pedro? That is correct. Empirical. All right. Now, to make sure we got it clear, if this is empirical, what will make it classical? Tell your neighbor, please. What would make it classical probability? Let's see. What would make it classical, Zach? Yeah, it's not in the notes. It's either you know it or you don't. Dom, help him out. Not doing the frequency, so what do I do? Outcomes, probability. What are the outcomes? Heads, tails. What is the probability of a head? 1 out of 2. 1 out of 2. That is classical. Why? Because they both have equal amounts of probabilities. I heard some of you said 4 out of 8, 4 out of 8. Yes, because it's still 1/2. Okay, so keep that in mind, please. Once again, empirical, notice that they're not equal. Classical, they are equal. All right. Copy the agenda for today, please. Warm-up number 70, Intro to Probability. Today we'll be done with this sesh. And your home plate for tonight, pages 198, 199, number 17 to 21 only. And once you copy the agenda, make sure you go to Canvas, turn in numbers 1 through 16. 1 through 16. There's a new module titled Chapter 4, Chapter 4, Probability module. All right. So, Last night's home play was this one. Yes? Make sure you turn that in as well. It was applying concepts. All right? So once again, tonight's home play, number 1721. And let's get started. Get a Cornell note ready, please. You don't need a fair model. We're going to go pretty swiftly to today. I just have a couple more things to cover, and then we're done. Our objective for today, I can identify and compute the basic probability. I can identify and compute basic probability. I can identify and compute basic probability. All right. So where have we been? Well, now we know the difference between, we started with classical and empirical. And at the beginning, I started with a classical, gave you guys the formula for that, yes? From there, we went to empirical, gave you guys the formula for that as well. From there, we came back to the to make sure we understood classical versus empirical, and we just saw an example today on the warm-up. And then from there, we returned back to our concept map, and we said we haven't covered subjective. And yesterday, I gave you guys a video to watch, and then from there, I asked you guys some data from there. So just to make sure we got it down, don't write this down, but tell your neighbor what's the difference between classical, empirical, and subjective probability. What's the difference between classical, empirical, and subjective probability? All right, so I think we got it. Looks like Maddie, JC, and Pedro's got this. Very good. Jet got it. So let's see. So we know classical and empirical. We just saw it on the warm-up. What is subjective, Jet? Let's go! When people make educated guesses, and that's why the probability might not be as accurate. That is correct. And that's why yesterday you saw that everybody had a different opinion as to what they saw Jeremy Lin in regards to scoring a basket or an assist. That's a brick right there. All right, so then from there we came back and we saw this again just to cover what we talked about in regards to the law of large numbers. Law of large numbers. What does that mean? That if we only toss the die, let's say 6 times compared to 30 times, as we get closer to the 30 times or 30 mark, it all of a sudden becomes more like of a classical. All of a sudden we end up having an even amount of probability for all the outcomes. Okay. And then we talked about terminology. You guys have that. We talked about probability rules. We got those. And here's another rule. Copy this one, please. It's called Rule of Complementary Events. Rule for complementary events. And all it is, we've already experienced this the other day, and we talked about how half, when was it that we saw that? We were talking about, what was that we were talking about? Was it the die? No. I think it was a coin toss. No. It was the 2 die. Remember when we started with that activity with the 2 die? And all of a sudden, we talked about that some of it was going to be half and the other one was going to be the other half. But at the end of it all, they all needed to be equal to what? 1. So this is just the same thing. The only thing they address it, P of E means probability of events, and P with a E bar, that's what we call the complementary probability of its complementary event. And both of those are equal to 1. Now, if we wanted to solve for one or the other, then probability of event is 1 minus its complement, or to find out what the complement is, 1 minus the probability of event. And that's basically what it is. And to put it in terms in regards to a coin toss, it would be like this. So, if I was to want to get a tails from flipping it, what would be my probability, guys? 1/2, is that correct? So that means this would be my P of E. P of E would be tails to be 1/2. So let me look at here. I'll use this one. P of E is the same as if I was to look for 1 minus the probability of its complement of the event. So what would be the complement of a tails? It would be what? Heads. And what is the probability of a heads? 1/2. So that means the probability of the event, which is for tails, is the same as 1 minus 1/2, which is 1/2. So that's all they're saying. And this is one part where people start getting confused because of the terminology, but it's simple as long as you understand what you're looking at in regards to just an equation that they're just manipulating, and it's the same equation. Okay? Yes, Mr. Q? Everybody got it? All right. So, it's the same equation, but just 3 different ways of rewriting it. Okay, let's move on. Copy this one, example 1. Build a tree diagram for all outcomes of flipping a coin 3 times. Build a tree diagram for all outcomes of flipping a coin 3 times. All right? So, we're going to write coin. All right, get us started. Outcomes, Andrew. Heads, tails. That's the first flip. We go to a second one. All right, second flip. Outcomes, everyone. Heads, tails, and heads, tails. Okay, that's the second flip. Everybody following? Yeah? Let me move this down. Hold on. To make some room. Bam! Love technology, man. When it works. All right, let's go to the third flip. Heads, tails, heads, tails, heads, tails, heads, tails. So, let's write all the possibilities of the sample that we're looking at. All right? Get me started, Vince? For all 3 of them? Yeah, get us started with the combinations. Oh my goodness. Heads, heads, heads. Okay. Yeah. Let me highlight it so you guys can see it. Next one, Marco. Heads, heads, tails. Very good. You guys see it? All right. Next one, Amy. Yes. Which is right here. Next one, Zach. Heads, tails, tails. Jess, can you get the light, the right light? Turn it off, please. I think because of the light, it doesn't. Is that better right there? Yeah? All right. JC, next one. Tails, heads, heads. Yes. Maddie? Yes. Tails, head, tails. Okay. We could have gone tails, tails, tails. That's fine, but just keep in order and not lose track. All right. Pedro? Tails, tails, heads. Very good. And the last one. Maddie? Yeah. Tails, tails, tails. And those are all the samples for the 3 times we flip a coin. Woo-wee. So many famous, how comfortable are you with building a tree diagram? Yeah, just be careful. Keep organized. If you want to use color so you can keep organized when you get all the samples. Because right now it's going to get pretty crazy. Y'all ready for the crazy? Your example? All right, here we go. Example 2. It reads, build a tree diagram for all outcomes of a paper, rock, scissors game, 3 turns. 3 turns. Copy and go. So if you need to write small and don't make the branches too long, that's cool. I'll give you some time. Go. All right. So let's see. I'm going to get started. Paper, paper, paper. Devin, continue. Paper, paper, rock. So I did paper, paper, paper. Okay. And then paper, paper, rock. Okay. Continue, Andrew. Let's go. All right. Continue. Mel. Paper, rock, paper. Continue. And. Woo. Yes, so far so good. So paper, rock, rock, rock. Rock, paper, rock, rock, and rock, scissors. Okay. Continue. Change. And then. Okay. So this same one for this one, this one, this one, and this one. Okay. Whew. Eric, go. We already got paper, paper, paper. Now we are here. Yes. So I'm going to continue here. Rock, paper, paper, and then? Uh-huh. Thank you. So that one with this one and these 3. Okay. All right, continue, Samuel. Uh-huh. Yes. All right. Continue, Matthew. Rock, scissors, paper. Thank you. So rock, scissors, and these three. Okay. And these three. All right. Are we done with rock? All right. Continue, Aaron. Uh-huh. No, let's stay with paper. Uh-huh. So it was scissors, paper, rock, and scissors, paper, what? Yes, thank you. So we are at scissors, paper, 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 rock, paper, scissors. Okay. Continue. Jared? Whoa. Hold on. Don't close. There you go. So we said scissors, paper, scissors, rock, paper. Okay. Scissors, rock, and scissors, rock. Yes. Okay. So we got this one with its three. All right, and the last one. Woo. Alejandro. Uh-huh. Uh-huh. Woo. Let's go. Should we go one more turn? Anyways, from 1 to 5, how comfortable are you building tree diagrams? Yes? 5, 5, 5? Okay, good. All right. So, I want to stop right there. That's as much as I needed to cover. So your home play for tonight is number 17 to 21. I'm going to put those on the screen over there so you can work on those for the rest of the period. Do as many as you can, and I'll stop the video right here. Bye.